Swayam Prabha. Digital India. Educated India.
Discussing the module 7 of the organic chemical technology course, and in module 7 we are discussing about the various petrochemicals which being manufactured. Already we have taken 7 lectures on the petrochemicals, and that was the introduction to the petrochemical. Then it was the naphtha cracking, recovery of the FCC gases. Then we discuss about the synthesis gas, ethylene and the propylene derivatives. Now today we will be discussing about a very important topic. Already we discussed in the last lecture about the aromatic production. So we will be discussing about the aromatics product profile, ethyl benzene, styrene, cumene, phenol, bisphenol, aniline and phthalic anhydride also. The coverage of the lecture will be introduction, product profile of aromatics, benzene, toluene, xylene, world aromatic petrochemical scenario, ethyl benzene and styrene manufacture because for the manufacture of styrene we need the ethyl benzene, and for the ethyl benzene we need the ethylene and the benzene, and so that is the styrene, that is the major outlet is for the manufacture of the resins and synthetic rubber. Another important product of BTX is the phthalic anhydride, cumene and the phenol, bisphenol, aniline. So aromatics, as we discussed in case of, if it is the ethylene is the king of the chemicals, so aromatics is the backbone of organic chemical industry. And before coming of the cracker, there was the aromatics in some or other form, and one of the route was the your coal open gas, coke open gas, and already we discussed about the coal chemicals and the aromatics with different type of the aromatics which we are getting, and even the, you see the, now we are talking about the orthoxylene for phthalic anhydride. Earlier it was the naphthalene route which was produced from the coke oven plant. So this is how the importance of the aromatics have been big, but actually the ability of the aromatics, that was more only after the coming of the catalytic reforming, because you see the requirement of the aromatics are huge. And if you see the product profile of aromatic, the aromatic hydrocarbons, especially benzene, toluene, xylene, BTX and ethyl benzene are major feedstock for the large number of the intermediates which are used in the production of the synthetic fiber. You take the case of the benzene, we are producing the cyclohexane, cyclohexane to caprolactam. Similarly, other xylene to your paraxylene to TPA, purified terephthalic acid, or the DMT. Similarly, resins, various resins we are making, polystyrene resin, one of the important resins, synthetic rubber SPR and other rubbers are there, where we are using the huge amount of the aromatics, explosive TNT, that was the one of the very important explosive during the World War I, World War II, and so TNT that played important role. So pesticide, benzene hexachloride, which called it the gamexine, that was the first pesticide which was made from this benzene, that was the benzene hexachloride. After the DDT, that was banned on the DDT. Detergent, linear alkyl benzene, I already discussed about the linear alkyl benzene and the importance of the linear alkyl benzene, where we are using the benzene for the alkylation process, dyes and intermediates, where the huge amount of the aniline that is being used for the production of the dyes intermediate. These are the some of the derivatives of the benzene. So, from the benzene to cumene, cumene to phenol and the acetone, because during the manufacture of phenol from the cumene we are also getting acetone as a byproduct. So, the phenol outlet is for adipic acid, aniline, bisphenol, that is one of the very important product of the phenol which is going for the manufacture of the polycarbonate. Then the caprolactam, phenolic resin, pesticide, dyes, rubber chemicals, acetone, methyl isobutyl ketone, methyl methacrylate solvent, methyl isobutyl carbinol. Cyclohexane, that is the another derivative of the benzene that we are making, and that is going for the manufacture of the caprolactam, nylon 6, nylon 66, adipic acid, linear alkyl benzene, that is going for the manufacture of the detergent, the biodegradable detergent. And with the coming of the linear alkyl benzene, there has been lot of the change in the your detergent industry because of the availability of the raw material from the petrochemical route. Another derivative of the benzene, that is the malic anhydride, which is finding the wide application as lubricating additives, copolymer, agriculture chemicals, unsaturated polyester resin, 1,4-butadienol. These are some of the product outlet for the malic anhydride. Chlorobenzene was the route for the aniline or the nitrobenzene that we are using. So, for making that the chlorobenzene, chlorination of the benzene, that was the route. So, aniline, phenol, DDT, chloronitrobenzene and diphenyl. So, these are some of the other important nitrobenzene. As I told you, the nitrobenzene that is being used for the manufacture of the aniline, dyes and intermediate, rubber chemicals, drugs, pharmaceutical, photographic chemicals, isocyanate. BSC, that is that is being used as pesticide, ethyl benzene, that is one of the very important derivative of the benzene which is going for the manufacture of the styrene. And so, if you see the styrene, the polystyrene, SPR, ABS, acrylbutadiene, styrene, polymer resin, ASEAN resin, acrylonitrile, butadiene, styrene, plastics, protective. So, these are some of the outlet for the then the Styrene, you see that they are having less usage of the Styrene normally, but one of the major use is the manufacture of the benzoic acid, where the benzoic acid Styrene to benzoic acid and benzoic acid to caprolactam, that route is existing, but mostly what we are doing, we are going for the disproportionation of the dealkylation of the Styrene for getting the more value-added product benzene and the xylene. And this is about the benzoic acid. Then the phenol, sodium benzoate, that is the one of the very important preservative that we are making from the benzoic acid, that is the sodium benzoate. Paracrystal, solvents, these are some of the outlet. Of course, that the TNT which I told you, that is the very important product, trinitrotoluene. Nitrotoluene, that is going for the toluene diisocyanate, which is used for the polyurethane, rigid foam, flexible foam, surface coating. Trinitrotoluene, as I told you, that one of the very important explosive, because in your toluene that was available earlier from the coke oven plants also. So, but with the coming of the this catalytic reforming plant, more and more toluene is available. So, the explosive, that may be the one of the very important derivatives from the styrene which is being used. But although the lot of the other explosive that has been also developed. So, the another important product of the this aromatic group is the paraxylene. Paraxylene, that is used for the manufacture of the polyester, means the first paraxylene to DMT or the purified terephthalic acid. So, the consumption of the paraxylene is estimated to have increased by approximately 4.7% in 2009. It is expected to average growth of 5.5% per year from 2009 to 2014 and 3.5% per year from 2014 to 2019. This is per as the market analysis of SRI. So major use of the paraxylene, as I discussed earlier, also is in the manufacture of DMT purified terephthalic acid, which is used in the manufacture of polyester fibers, films, and the polyethylene terephthalate, polyethylene terephthalate. So this is the one of the major outlet for the paraxylene, and so this is the integral part of the any DMT or the terephthalic acid plant where we are making the polyester. Another important product which we are getting from the catalytic reforming, and when we are doing the paraxylene manufacture, the orthoxylene, that is a byproduct of the paraxylene plant. And so now the orthoxylene, a major portion of the orthoxylene that is going for the manufacture of phthalic anhydride. So the global production consumption of the orthoxylene in 2009 were approximately 3.7 million tons. Global capacity utilization was 66%. Orthoxylene consumption is estimated to have increased slightly in 2009, and it is forecast to average growth of 3.2% per year from 2009 to 2014. So this is the how the requirement of the orthoxylene that is increasing, and especially the for the manufacture of the phthalic anhydride. So these are the some of the major derivative of the orthoxylene, that is the phthalic anhydride, which is being used plasticizer. One of the major use of the phthalic anhydride is as plasticizer, polyester resin, alkyl resins, dyes and pigments, herbicides, and the some other polyester polyols. So these are the some of the so for the metaxylene is concerned, one of the major derivative is the isophthalic acid, which is being used for the resins, unsaturated polyesters, and then the plasticizers and other esters. Paraxylene already we have discussed. And so this is the, as I told you, the orthoxylene, plasticizer, polyester resin, alkyl resin, dyes and pigments, herbicide, isophthalic anhydride, polyester polyols, and phthalimide fungicide that is being used. Another, actually the aromatic group is the naphthalene, which was the earlier route for making of the phthalic anhydride, because this was obtained from the cocoa bean plant. And so the major use of the naphthalene, apart from the other uses, insecticide, naphthol, and the mothballs and other uses, that was the one of the important source of the phthalic anhydride. So before coming of the paraxylene plant, the most of the phthalic anhydride that was being manufactured from the naphthalene route. So these are the some of the surface active agents, synthetic tanning agents, dyes, rubber, chemicals, solvents, agriculture uses. So these are the some of the uses of the naphthalene. So this is about the world aromatic petrochemical scenario, consumption figure of the benzene, toluene and xylene, and the changing scenario from 1992 to 2002 and 2007 to 2012. Consumption growth, that will be the in percentage 3.5 for benzene, from 3.5 to 2.8, 1.9 to 2.4, ethyl benzene 4.2 to 2.7, and then the styrene 3.9 to 2.7. Mixed xylenes, similarly mixed xylenes, xylene, paraxylene, these are the some of the consumption figure, and the growth, consumption growth during the period 1997 to 2002 and 2002, 2007 and 2007, 2012. This is about the cumene, phenol, caprolactam, phthalic anhydride, and toluene diisocyanate. So these are the some of the figures from where you can get an idea of the how important is the aromatic compounds which are being used in some or other form in our daily life. This is about the terephthalic acid and the dimethyl terephthalic. So here also, if you see the consumption, that is the growth rate, and other, earlier it was the terephthalic acid, huge growth was there in case of terephthalic acid. Slightly that has gone down, but the requirement that is increasing. This is the present capacity and production scenario of the benzene, toluene and xylene in India. So, this is the figure. You can here also you can see the benzene production, toluene is less, and the more orthoxylene, the paraxylene is there, because the paraxylene requirement, that is going in the major portion, around 70%, more than 70%, that is going to for the your terephthalic acid or the DMT. This is the installed capacity and production capacity of the major intermediate, where the aromatics are involved. Acetone I have given because we are getting as a byproduct from the cumene plant while making the phenol, aniline, benzene, nitrobenzene, orthonitrotoluene, orthoxylene, paraxylene, phenol and phthalic anhydride. So, this is the installed capacity of the various aromatic product we are getting, and this is the production figure. This is in the multiply by 1000 metric ton per annum. So, this is the about the install and production capacity of the major intermediate during 2009 to 10. This is the again installed capacity and production of the various aromatics, major aromatics during the 2009 to 10, about the benzene, toluene, mixed xylenes, orthoxylene, and one of the another important product, linear alkyl benzene and the phenol. So, these are the installed capacity and this is the production figure, and so the your capacity utilization that may be. So, the ethyl, let us now discuss some of the important derivatives of the benzene in more detail. In this series, that will be the first, that will be ethyl benzene, because ethyl benzene you see that is being used for the manufacture of the styrene, and during the World War I and II, that was the huge requirement of the styrene butadiene rubber at that time. So, the even before coming of the petrochemical also, the styrene, that was, as you see in case of the synthetic chemicals, barely they started making styrene butadiene rubber long back during the 60s. So, this is the importance of the ethyl benzene. So, ethyl benzene important derivatives of the benzene which find application in the manufacture of styrene. Ethyl benzene with the demand share of more than 52% of the global benzene market, where we are alkylating the benzene with the ethylene, and ethylene that was coming through the molasses route at that time in the earlier stages when the styrene manufacture that was started. Global production and consumption of ethyl benzene in 2009 were around 26.3 million tons with the global capacity utilization of 75%. Styrene manufacture is the major consumer of the ethyl benzene. Let us discuss now what are the routes for the making of the ethyl benzene. Ethyl benzene, as you say, the ethyl and benzene, so that is the made by the alkylation benzene and the ethylene, and so again here also the same the catalyst about the H2SO4 to hydrofluoric acid and now to the solid acid catalyst. So, these are the some of the development that has taken place. So, ethylene, because we need the benzene and ethylene, so ethylene can be produced from either molasses route or the naphtha and the gas cracker. But with the increase in the FCC, and because the more and more we are going to operate in the propylene mode, so there has been interest in the utilization of the FCC gases, where the ethylene that may vary from 8 to 12% as source of ethylene, and direct taking this ethylene for the alkylation, the processes are now available. The conventional, as I told you, in case of the alkylation catalyst, where the metal chlorides and the mineral acid, hydrofluoric acid and the H2SO4. Catalysts used for alkylation now are the ZS5 for vapor phase, MCM22 for liquid phase. The catalyst use, already I discussed the ethyl benzene, some of the technology which are available for the manufacture of ethyl benzene, that is the catalytic distillation then the EOP EB1 process, mobile Baser EB Max process. These are the three major process licenses for who are supplying the process for the ethyl benzene technology. Now let us discuss the first process, that is the catalytic distillation technology, because this is one of the major development that has taken place in the process consists of the alkylation of the benzene with ethylene using a proprietary zeolite alkylation catalyst in a fixed bed catalytic distillation technology, where both the reaction and slight separation that is also taking place. This process is capable of handling a wide range in ethylene composition ranging from 10 to 100%, because in case of the dilute stream of the ethylene, that can be also used in this process. So, process step involved in case of the catalytic distillation technology is the first is the major unit is the catalytic distillation stripper column, where alkylation distillation takes place simultaneously with the final alkylation of the unreacted benzene and ethylene in the finishing reactor, where the remaining benzene and ethylene alkylation that is completed. Finally, the product stream is fractionated to separate ethyl benzene and the polyethyl benzene, which is also formed during the process, which is recycled to the transalkylation section and the flux oil. So, these are some of the byproduct, the polyethyl benzene and the flux oil. So, polyethyl benzene, that is again converted, that is being recycled, but the flux oil, that is the waste we are getting from the ethyl benzene plant. Another process, that is the Loomis EOP EB1 process. The process consists of liquid phase alkylation of benzene with ethylene using proprietary zeolite catalyst in a fixed bed liquid phase reactor. So, this is the process by Loomis and EOP. Unreacted ethylene and benzene vapor are condensed and fed to the finishing reactor, where the remaining alkylation is completed in the presence of the catalyst. So, here also the two reactors are there, and so the finishing reactor that will complete the reaction. The product stream goes to the fractionating column, where ethyl benzene is separated from the higher ethylated benzene and the heavy ends. The process steps involved are the, as I told you, the benzene and ethylene, followed by separation of ethyl benzene and the polyethyl benzene, which is here also the byproduct, and which is recycled back to transalkylator reactor. This is the finishing stage reactor to produce the additional ethyl benzene. Another process, the liquid phase alkylation of benzene with ethylene using MCM22 catalyst. This process, alkylation of ethylene, takes place in a liquid filled alkylator reactor containing multiple fixed beds of mobile MCM22 catalyst. During the here also the alkylation methyl benzene and small quantity of polyethyl benzenes are formed, which is converted to ethyl benzene using transalkylation catalyst. So, this is the reaction which is taking place here, the alkylation reaction. Now, this was the process for making of the, because any styrene plant, that will be the combination of ethyl benzene and then the styrene manufacture. So, this in case of the styrene is a monomer used for the production of the polymer, resins and rubbers. The biggest consumer of the styrene monomer is the polystyrene. Other major derivatives are expanded polystyrene, styrene butadiene latex, styrene butadiene rubber, styrene block copolymer with the combination of the acrylonitrile, ABS, MBS or the SPS. So, styrene is a global production and consumption of styrene was approximately 23 million tons with a global capacity utilization of 77%. Largest end use of the styrene is for the production of the polystyrene, accounting for almost 60% of the total styrene. So, the process of making styrene, that is the styrene is made by the catalytic dehydrogenation of the ethyl benzene. So, this is the process that we are using. Styrene plant consists of the two major units: production of the ethylene either from molasses route or by naphtha natural gas cracking, production of ethyl benzene, and then the dehydrogenation of the ethyl benzene to styrene. This is the Lummus UP-EB1 process. In this process, first the alkylating engine with ethyl benzene followed by dehydrogenation of the ethyl benzene to form styrene. So, the polyethyl benzene which is formed during the alkylation is fed to the finishing reactor, where the alkylation reaction is taking place. So, these are the some of the reaction that is taking place in case of the your styrene manufacture. First it will be the ethyl benzene and some of the higher your higher polyethylene benzene that will be converted to again ethyl benzene. So, this is the dehydrogenation process that is taking place. Finally, ethyl benzene, that was the during the manufacture of the ethyl benzene. So, ethyl benzene and recycled ethyl benzene are then dehydrogenated to styrene in the presence of steam at a pressure temperature of 550 to 568 degrees centigrade under vacuum in a multi-stage reactor. So, this is the reaction that is taking place, but toluene is also formed in the process which is recovered. Another process technology for manufacture of the styrene is the GT styrene. Styrene can be also directly recovered from the raw pyrolysis gasoline derived from the cracking of naphtha gas oils using the GT styrene process. Here what is happening in case of the, as I told you, during the manufacture of the aromatics along with the other C8, means the paraxylene, orthoxylene, ethyl benzene is also there. That ethyl benzene that is separated, and that can be used for making of the styrene. As I discussed, I told you that the even the ethylene part, that the ethylene which is available from the FCC gases, that can be also used. So, here directly ethyl benzene, because from the pyrolysis gasoline that can be separated. This is the another very new development in case of the styrene technology, that is the innovative snow technology. The snow technology has been jointly developed by SwayamPrabha and the Dow, represents a technological and economical breakthrough in styrene production and uses benzene and ethene as raw material, which is dehydrogenated in the same reactor for ethyl benzene, because dehydrogenation of the ethane to ethylene, that will be there, and so that will be used for the ethyl benzene manufacture. Lummus UP classic styrene process. The process ethyl benzene is categorically dehydrogenated in vapor phase to styrene in presence of the steam. The vapor phase reaction is carried out at high temperature under vacuum. High purity styrene is separated by fractionation. Now, this was about the ethyl benzene, the styrene, which is one of the very important derivative, because huge amount of the styrene that is going for the making of the polystyrene. Another important product that has been in case of the benzene is the cumene to methanol, cumene to phenol. So, cumene is made by alkylating benzene with the propylene, and this was only actually this process why the cumene process came into that replaced the other process, because the propylene that is available from the cracker plant, benzene is available from the aromatic plant. So, the raw material definitely that is much economical than the conventional raw material which was being used for making of the phenol, that was the from the chlorobenzene route, or some other routes are also there. So the cumene is made by alkylating benzene with the propylene using zeolite catalyst. Following are the three major processes available: catalytic distillation technology, liquid phase Cumax process, cumene by mobile bezel process. These are the some of the reactions that is taking place in case of the benzene, propylene, and then you are getting the cumene. During the cumene manufacture, we are also getting and some which are some of the DIPB plus benzene to cumene, and similarly the other side reactions also take. But finally, we are getting the cumene. So this is the process where the propylene and the benzene along with the fresh benzene that is going to the series of the reactor, the alkylating reactor, the transalkylation reactor, deproponizer, and then the benzene column, cumene column, and the polyisopropyl benzene column. So the and that is the finally here the cumene is separated, and so that cumene will go for the making of the phenol. So this was the importance of the cumene, and now the phenol process, making of the phenol, it is all through the cumene process. So while making of the cumene to phenol, we are getting acetone, one of the very important product as a byproduct. So according to SRI Consultant Report 2010, global production and consumption of phenol were both around 8.0 million tons with global capacity utilization of 77%. Phenol consumption is expected to average growth of 5.1% per year from 2009 to 2014 and around 2.5% from 2014 to 19. Phenol is consumed mainly for the production. One of the major use of the although the phenol other uses also there. One of the major outlet that has been the manufacture of bisphenol, which is being used for the making of the polycarbonate. This is the cumene phenol acetone plant of the Hydrelia Chemicals. This is also one of the large integrated petrochemical complex where they are making a large number of the petrochemicals, and this is one of their very important product, Hydrelia Chemicals. Phenol from cumene, because as I told you, now all the phenols that has been replaced with the cumene process. So phenol from cumene is a two-step process, with the first step being the production of the cumene hydroperoxide, and the second step is the decomposition of the cumene hydroperoxide to phenol and acetone. So this is the which I told you that the acetone, that is a byproduct during the manufacture of the phenol. So temperature around 180 to 200 degrees centigrade. This is the pressure, catalyst, metal catalyst, aluminum chloride, bentonides, silica aluminates. So the various routes for the phenol, other routes are, as I told you, the other routes are there, and earlier the phenols was made by these the benzoic acid route or the chlorobenzene route or the benzene sulfonation route. But now the most of the phenol, the cumene process, that is most attractive process because of the availability of the benzene from the catalytic reforming process and propylene from the cracker plant or from the dehydrogenation of the propane. So the but these other routes are because benzoic acid, again from the toluene to benzoic acid, so from the benzoic acid to phenol, or from the chlorobenzene. But again in case of the chlorobenzene, you are taking the benzene, so that has to be chlorinated. So involvement of the chlorine is there. So because of all those reasons, now it is the more preferred route for the making of the phenol is the cumene route. Another route, that was the benzene sulfonation, where again the handling of the sulfuric acid is there. Above all route, the cumene route is the most economical and accounts for major phenol capacity. This is the reaction that is taking place in case of the your phenol manufacture, benzene, propylene, that is reacted, and then you are getting the cumene hydroperoxide, and from the cumene hydroperoxide you are finally getting the phenol and the acetone as a byproduct. So this is the oxygen of the aqueous solution. The cumene hydroperoxide is formed, and from the cumene hydroperoxide phenol plus acetone that you are getting. So this is the process that is being used for the manufacture of phenol. And this is the your phenol from the cumene process. So that will go to the cumene, will go to oxidation tower, distillation tower, then the cleavage reactor, catalyst you are adding here, crude acetone column, then it will go to the acetone column where the separation of the acetone that will take place, and from this crude acetone bottom product that will go to the phenol purification section where the phenol finally will be getting the phenol here. Here at the bottom again this will join to the phenol recovery section, then final distillation that will separate the phenol. So this is the, and you see the first will be the any phenol manufacturing in it, that will have the cumene manufacturing part, then the from the cumene to phenol recovery, the means the finally you are getting the phenol here, and the acetone that will be a byproduct of the cumene process. Now let us discuss another very important product of the benzene, that is the aniline, which is being used in huge amount as a dye intermediate. So aniline is used as a raw material for manufacture of large number of the chemicals like methyl, diphenyl, isocyanate, that the MDI, rubber processing chemicals like antioxidant, stabilizers, antioxidants, agriculture chemicals include aniline based fungicide, insecticide, animal repellents, and the different dyes and pigments, especially the fiber, for the fiber, then the pharmaceutical and the petrochemicals. But as I told you, the large tonnage of the aniline derivatives are used in the large variety of the dyes, because now the a wide variety of the dyes depending upon the type of the your textile that has been developed, and so the aniline that has been providing the basic intermediate for making large number of the dye. A major portion of the aniline is used in the manufacture of rigid polyurethane also. This is the, you see the major portion of the aniline that is going as the colorants and the manufacture of your dyes. So rest of the other usually pharmaceuticals and other derivatives, rubber chemicals, but major portion that is going as the coolant. These are the major uses of the aniline. If you see the aniline to hydroquinone, acetylite, then the diphenylamine, 2-MB2 diphenyl guanine, the phenyl naphthylamine, beta naphthol, that is one of the very important intermediate which we are using in the dye industry. So this is the for making of the azo dye, although there is ban on the use of the azo dye, but these are the some of the again the dimethylamine is also going for the for your dye stuff and the explosive. So these are this a large number of the products are there which are 2-MB2 that is going for the vulcanizing and the acylator as activator for acylator, that diphenyl guanidine. So these are the some of the major outlet of the aniline, and the even as you see the before coming of the aromatic plant, the root was for making the benzene aniline, again it was through the cocoa plant, the aromatic from the cocoa plant. So this is the production pattern of the aniline in the year 2010 and 11. This is in India. Gujarat Narmada Valley Fertilizers GNFC, that is one, and Hindustan Organic, they are the major producer of the aniline. GNVFC is the one of the large integrated petrochemical complex where they are making also the fertilizer, and at the same time many of the petrochemicals. So now they have two divisions, one is the fertilizer division and the is the chemical division. So aniline nitrobenzene is the important feedstock for the aniline, and the major portion of the nitrobenzene is used directly or indirectly as aniline in dye manufacture. This is the reaction in the manufacture of aniline. Aminolysis of the chlorobenzene, and is produced by aminolysis of the chlorobenzene at 200 to 220 degrees centigrade, and the other vapor phase reduction of the nitrobenzene. So this is the from the nitrobenzene route, this is from the chlorobenzene route. So both the routes were earlier used for making of, and the still that is being used for making of the aniline, that is either through the chlorobenzene route or from the nitrobenzene route. This is the method for the aniline manufacture. Nitrobenzene and hydrogen, that is going to vaporizer, from the vaporizer to your this is the catalytic reactor cum distillation column, where the reaction is taking place, and then the finally it is going for the, after the separation of the catalyst, it is going to separation of the aniline and the heavy end. So this is the process that we are using for the making of the aniline from the nitrobenzene route. So now let us discuss about the bisphenol, which is one of the important derivative I told you earlier also, because this is the major raw material for polycarbonate and major consumer of the phenol, because the phenol and the phosgene that we are using here, that is going for the making of the bisphenol. And so the bisphenol and the, now we are seeing the your polycarbonate, and the bisphenol is used for the manufacture of the polycarbonate plastic and epoxy resin. It is also used in as the inflammation retarders, unsaturated polyester resin, and polyacrylate, polyethylamide, and the polysulfone resins. One of the major outlet is for the bisphenol, that is in the polycarbonate, optical glasses, and the many of the, because that is having very high strength, so that is being used the polycarbonate. Even the CD and other in the electronics industry also, a lot of the uses of the polycarbonate is there. So technology, the condensation of the phenol with the carbonyl component compounds, condensation of the phenol with the alkaline phenol, condensation of the phenol with the ethylene and acetylenes, condensation of the phenol with the alkyl. These are the some of the routes available, but major and they actually the major process which we are using for the making of the bisphenol is the either by ABS Lummus Global Sinopo technology, or it with the Chiodo Corporation CTP circle. This is the some of the advantage low capital technology suitable for optical grade polycarbonate from phenol and acetone, because the huge application of the polycarbonate is for making optical glasses also. So the another process for the manufacture of bisphenol, phenol and acetone, the process can produce both grades of the polycarbonate and epoxy resins. Let us discuss the process technology in case of the bisphenol. Amongst the various process technology mentioned above, acid catalyzed condensation of the phenol and acetone is only commercial route commonly used for the various bisphenol manufacture. So this is the phenol and acetone are mixed in the 3% 3:1 molar ratio in 4 glass line stirred reactors at 50 degrees centigrade and 1 atmosphere pressure using anhydrous HCl catalyst and methyl mercaptan as promoter. The residence time is around 3 hours in each of these 4 reactors. This is the reaction that is taking place during the manufacture of the bisphenol. This is the process flow diagram for the manufacture of bisphenol from the phenol and acetone route. So that is the phenol, acetone, methyl mercaptan, hydrogen chloride that is going to the reactor. From the reactor, the product stream is going for the separation of the HCl and other impurities which are present. So that is the pure water, phenol. Then after the phenol recovery, the heavier end that is going to the evaporation, crystallizer, purification, dye, and finally you are getting the bisphenol. So this is the process technology for the manufacture of the bisphenol. Now let us discuss one of the another very important aromatic compound which is finding large application in the paint industry. So installed capacity of phthalic anhydride in India is approximately 2,67,200 tons per annum. Major producers include the IG Petrochemicals Limited and Thermole Chemicals Limited. Naphthalene and orthoxylenes are the two major raw material for the manufacture of the phthalic anhydride. Use of phthalic anhydride: 29% is plasticizer, 27% is dyes and pigments, 28% is the alkyd agent, and 16 others. This is again the phthalic anhydride plant of the Ardelia Chemicals. So the process earlier, as I told you, the naphthalene route, that was the only the raw material that was naphthalene available from the coke oven plant. So that was being used for the manufacture of phthalic anhydride. So here phthalic anhydride is produced by oxidation of the naphthalene in the gas phase using vanadium pentoxide catalyst supported on silica or the silicon carbide, promoted with the various other metals oxides like titanium oxide in either a fixed bed, multiple reactors, or the fluidized bed reactor. But now all the phthalic anhydride we are making from the orthoxylene route. So production of the phthalic anhydride from orthoxylene is similar to the naphthalene route, but here we are using the orthoxylene, and so the catalytic oxidation orthoxylene is done either in the fixed bed catalytic reactor or having multi-tube or the fluidized bed reactor. Now the fluidized bed is more common in the presence of the vanadium pentoxide and the titanium oxide catalyst. So this is the reaction that is taking place during the manufacture of phthalic anhydride, oxidation of the orthoxylene to the phthalic anhydride. So this was about the various aromatic petrochemicals that we are manufacturing, their uses and application, and because the aromatics are equally important. And the next modules 8 will be discussing about the polymer industry, because the polymer means the plastic, elastomer, or the synthetic fiber, in which these aromatics are also finding wide application for the making of the various feedstock. So the next few lectures will be about 8 lectures are in module 7, where we will be discussing about the different type of the starting from the polyolefins to the PVC, then the polystyrene manufacture, and then the manufacture of synthetic fiber, caprolactam, and nylon 66, then the terephthalic acid, and also we will be discussing in that part the viscose rayon and the acetate rayon, which is also one of the important segment of the synthetic fiber industry. So this will be the next 8 lecture will be on the polymer, elastomer, and synthetic fiber in the module 8, and after that the last module will be on the pesticide and dyes and intermediates.